intensity of EM wave. Intensity means the rate of flow of energy per unit area perpendicular to the direction of the wave propagation. The rate of flow of energy per unit area held perpendicular to the wave propagation is called intensity of EM wave denoted by I. So now this unit is your joule per meter square per second, or this is equal to watt per meter square. Watt per meter square. This is the unit, and that you can have the dimensions. This is now your M1 L2, that will cancel by this one, L0 T minus 3, M1 L0 T minus 3. This is the dimension of this intensity of the EM wave. And this intensity is also given by formula I equal to UAV into C, where UAV, this is now average energy density, C speed of light, speed of light. So now this is so much watt per meter square. Right. Watt per meter square. Now this U average, this is equal to half epsilon naught E square, and this is also equal to half B square upon mu naught. E the electric field, B the magnetic field, epsilon naught the electric permittivity of the free space, mu naught the magnetic permeability of the free space. So now we can have that this intensity I, so I is equal to, now this is half epsilon naught C E square, and this is also equal to half epsilon naught C into B square. So what do you find from here? That this intensity is directly proportional. Now here this average intensity that we take, this half epsilon naught E naught square, this is now V naught square, E naught square, this is now your V naught square. These are the amplitudes of the electric field and the magnetic field. The electric field E equal to E naught sin kx minus omega t, and the magnetic field this B is equal to B naught sin kx minus omega t. Right, so this E naught and B naught are the amplitudes. So we can have that this I. Therefore, number one, this I is proportional to E naught square, and second, this I is proportional to B naught square. This is proportional to the amplitude, as we also know that the intensity always depends upon the amplitude of the wave. Now the intensity Pi is equal to P upon A. As I have told you, this is now watt per meter square. Watt the power per unit area upon A, the area. So P the power of source, A area of the surface So now for point source, what we have, that if suppose this is now your point source, this is now S, then the wave will propagate in all directions. These are the waves. This is now source, and these are the waves. So this is the spherical surface. So in that case, now this I is equal to P upon 4 pi r square, or the distance. Suppose we are having the so much, this is now suppose surface. This is now surface, then this is now distance r. So then we have this I equal to P upon 4 pi r square, because this surface is spherical. Spherical surface. So now what we have, that this I is proportional to 1 upon r square. It follows inverse square law. So now we can have that this I intensity on this side, we take the distance on this side, then it decreases very fast. So as the distance increases, the intensity of the wave decreases. It means that the energy of the wave is lost in the medium. And also it depends upon the power of the source. So I is proportional to P. So for different sources the intensity is different. And this I is proportional to P. Larger the power of the source, larger will be the intensity. So now we can have the variation of this one like this. This is now I, this is now your P. So this is a straight line. This I is proportional to P. This shows that for different sources, as the power of the source increases, the intensity of the electromagnetic wave emitted by the source will also be large one. For slit source of EM wave, so sources may be either in the form of the this point in the free space, and it may be in the form of the slit. Then this intensity I is proportional to 1 upon r. Now area will be this 2 pi RH. This is simply the cylindrical area. So r the distance and the radius of the cylindrical wavefront of this one, and h the height of that one. So that will be, as this wave proceeds away from the light source, then this intensity decreases. This we call the light slit source or the line source. Slit or line source. Now we have if suppose medium is non-homogeneous, this we take all these sources in the isotropic homogeneous medium, but the medium is not isotropic and not homogeneous, but it is the heterogeneous, then this variation of the intensity of the light source of this electromagnetic wave is somewhat different. In non-homogeneous medium, this intensity, this U average average equal to n square epsilon naught E naught square upon 2. This is not like this. And the intensity will be how much? Intensity I equal to U average into V. This is now velocity, where V equal to velocity of light in medium. So this V is equal to C upon N. This V equal to C upon N. So now intensity will be how much? I is equal to, now this is now U average, so this U average equal to so much N square epsilon naught E naught square upon 2 into, this is now C upon N. So one N will cancel from here, so this I is equal to N epsilon naught E naught square upon 2 into C. This is now intensity. So now what we have? Therefore, this I is proportional to N, and the refractive index, where N equal to refractive index of medium. So when the wave travels in the non-homogeneous medium, then it depends upon the refractive index of the medium. When we take the linear isotropic and homogeneous medium, then this N is equal to 1. But in case of non-homogeneous, this N is not equal to 1, but it has some different value. Suppose the wave travels in sub-transparent medium, like the liquid or the glass, etc., then this N will be different one. So in that case, as the value of N increases, the intensity of the wave also increases. So this is about the intensity of the electromagnetic wave. So when this is asked that what is the dimensional formula, what is the unit, and what is the definition, sometimes definition is given in the different ways. But always remember that this is the rate of flow of the energy per unit area. The area is always held perpendicular to the direction of the wave propagation. So now if suppose this we have so homogeneous, non-homogeneous, and suppose the sources are, whether this is a point source or the linear source or that the slit source, then what will be the intensity variation with the distance, that you can discuss, that you can answer from this topic. So this is what the intensity of the electromagnetic wave. So thank you very much.